Okay, so today we're going to talk about how to solve linear inequalities and the differences between solving them and solving linear equations. So the process of solving linear inequalities, it's the exact same process. You're still moving your variables around to all get variables to one side, constants to the other side, and then dividing or multiplying to get rid of the number in front of the variable. That's all the same. The key difference is when you're multiplying or dividing by the number in front of the variable. If that number happens to be negative when you're multiplying or dividing, you're going to have to flip your inequality sign. For example, you'll go from less than to greater than. You'll go from greater than to less than. You'll go from less than or equal to greater than or equal to. And finally, you'll go from greater than or equal to less than or equal to. And this only occurs when you multiply or divide by a negative number. If you're adding, subtracting, don't care. If you are multiplying by positives, don't care. I don't care if the other side's negative. It doesn't matter. It only matters when you're multiplying or dividing by that negative number. That's when it's different. Other than that, pretend the inequality is an equal sign and just solve like you would normally would. So for example, I want to solve for a here. So I need to move this 15 by subtracting. So we subtract 15 from both sides. 6 is greater than 2a. To get rid of the 2, we divide by 2. 6 divided by 2 is 3. Since I did not divide by a negative number, this stays greater than a. So 3 greater than a would be the correct answer to this equation. If I want to solve this one, same process again. I need to move this 7, so we subtract 7 from both sides. We get 30 less than negative 10w. We need to get rid of the negative 10, so we divide by negative 10. 30 divided by negative 10 is negative 3. Since we now divided by a negative, we need to change this inequality sign from less than to greater than, and then w. That's it. That is the only difference when we're dividing by this negative. Otherwise, it's the exact same process. If you have variables on both sides, it doesn't matter which side you move it to. You pick whichever side you would like. Common convention is to move the variable so that the coefficient stays positive, but it ultimately doesn't matter. So if I subtract 10h from both sides, we get 5h plus 30 is less than negative 45. We subtract 30 from both sides. 5h is less than negative 75. We divide by 5. H is less than negative 15. We didn't divide by a negative, so we never change our inequality sign. Had I moved the negative 15 to h over, we subtracted by that. So let me just rewrite that over here. We have 15h plus 30 less than 10h minus 45. Let's say we subtracted 15h first. We'd have 30 less than negative 5h. We add 45 to both sides. We get 75 is less than negative 5h. We divide by negative 5. So we get our negative 15. Divide by negative, so we flip the sign. Greater than h. And these two are the exact same answers. H less than negative 15 is equivalent to negative 15 is greater than h. And if you're ever not sure, for example, 10 is less than 15, and is negative 15, I'm sorry, not 10, negative 20. Negative 20 is less than negative 15. And negative 15 is greater than negative 20. They're equivalent. So let's solve this one. So first thing we want to do is we need to distribute this 2 to the entire expression. So we have 2y plus 4 greater than 6 plus 2y. To solve, I need to move the 2y's, so let's just subtract 2y from both sides. And we notice the y's will cancel out perfectly, leaving just this expression, 4 is greater than 6. Is 4 bigger than 6? No. So the answer is no solution. So similar to your equations, if your variables cancel out, you're left with a false statement. The answer is no solution. If you're left with a true statement, like for example, let's say you got this, 7 is less than 12, it would be infinite solutions. So again, false, no solution, true statement, infinite solutions. And again, it has to be that the variable cancels. If you have this kind of equation, like 8x is less than 0, variables didn't cancel, You can divide by 8 and x is 0. Two different concepts here. Here there are no more variables because they cancel. Here there still is a variable, so you can still get an actual number for your answer. Alright, one more. Let's deal with some fractions. So we have 2x minus 4 over 6 is greater than or equal to negative 5x plus 2. So to clear out fractions, we always multiply by the denominator to every single piece. When I multiply the left side by 6, the denominator cancels, leaving just the top, 2x minus 4, greater than negative 5 times 6 is negative 30x. 2 times 6 is a positive 12. So now we have this nice linear equation. So let's move the 30 by adding it to both sides. So we have 32x minus 4 is greater than or equal to 12. We add the 4 to both sides. 32x is greater than or equal to 16. We divide by 32. And we get x is greater than or equal to 1/2. You're obviously going to get fractions decimals. That's fine. Just make sure you either reduce the fraction properly or write your decimal properly as well. And again, I could have subtracted 2x from both sides and I would have gotten the exact same answer. Solve these the way you would solve any normal equation. Just remember to flip the inequality when you're dividing or multiplying by that negative number. Okay, so that's it for solving linear equations. Next time we're going to talk about compound inequalities.